So you are welcome in the part 2 of modeling spatial relationship video with the help of ArcGIS. And in this part, we'll discuss about the exploratory regression. And here, this is something about me. I'm Dr. Zubair Islam, working in the Department of Geography in Adigrat University, Ethiopia. And we'll discuss about the exploratory regression. ArcMap is open here, and the left hand side is the table of content where data is available, which we will use for our analysis. The right hand side is the R toolbox, and this is the spatial statistics toolbox. Under this toolbox, these are the tool sets, and our interest is the modeling spatial relationships. So when we model the spatial relationship, these tools will work on regression. And the regression tools provided in the spatial statistics toolbox, they model the relationship among the data variables associated with the geographical features, and they allow you to make the prediction for unknown values or to better understand the key factors influencing a variable you are trying to model. So regression method allow you to, we can say, verify the relationship and to measure how strong those relationships are. So there is what exploratory regression. Exploratory regression. This is the first one. So explore. We have to explore the strength of the relationship of the variables. So this exploratory regression tool, it allows us to examine the large number of ordinary least squares models quickly, and it summarizes the variable relationships and determine if any combination of the candidate explanatory variables satisfy all of we can say all of the requirement of the OLS methods. So this is the significance of this exploratory regression. We will use our data, and let me introduce my data here to you. Here, this is the Ethiopia, the international border, and within that border, here, these are the regions in Ethiopia, and within these regions, these are the zones. And the data which I will use is the urban settlement layers. These are the settlement layers basically, and these settlement layer, what these layers shows, let me show you by using this identity tool. If I click on this here, Meghale, then you can see here this data is giving us the information of the name of the place, the location. It is giving us the information that how many urban centers are within this large urban center, and what is the population there, and what is the built-up area, what is the nightlight data there, what is the GDP during 90 or 2000 or 2015. This is the other data is related to, means some data is related to socioeconomic, and some data is related to environment, and some data is related to these sustainable development goals objectives, and some data is related to hazards information also, like flood and storms. So we will use this data for our analysis. Here we can see by labeling the features like this. You see here, this is Meghale, and there are another names also: Bokro, Hausen, Adigrat. So all these are the places which we will see means the relationship among the variables. So the variables, as we can take the broad idea of the variables, like what is the population, what is the built-up area, what is the GDP. So of course, all these three parameters we see, then when the population is more, of course the built-up area will be large, and when population is high and built-up area is more, then GDP will also be, gross domestic production will also be the higher. But how much? And that how much question will we will give will take the answer from these tools by using these tools. So we will begin with the exploratory regression, and one more important thing is, out of these five tools under this tool set, that is the modeling spatial relationships tool set, these five tools, the our objective is to use finally to use this geographically weighted regression or ordinary least squares. And the first and third tools will help us to take the decision when we are using geographically weighted regression or OLS. And how these will help us, because this exploratory regression, it will not give us any map, it will not give us the our objectives result, but it will help us in the process of ordinary least square process. How it will do it, just have a look. We will open this. So before I start the practicing this exploratory regression, let's see this OLS. You see here, when you will click this OLS, you will input the feature. Okay, and this is my data here. Okay, and I have given the data, and I can give the unique ID here, and I can give the dependent variable is not a problem. Like if my dependent variable may be anything, like it may be population, it may be, suppose my question is that what is the reason why population is here, then my population will be dependent variable, and the explanatory variables may be the built-up area, maybe the GDP, maybe the some another variables. So at this moment I do not know that what variables, explanatory variables, I should choose. So for that very purpose, to see the strength of the influence of the explanatory variables, it is important to work on the exploratory regression first. So exploratory regression will help us to show us the strength of the relationship. So before using OLS, we will use, or before using this GWR, geographical weighted regression, that is the reason we should use the exploratory regression first. So I'm just making it cancel here, and uh, I will open this exploratory regression. So this is the window of exploratory regression here, and in this window you can find this is the input feature. You have to put your feature, like my interest is this, so I will put this feature here, and I have to give my dependent variable. Suppose if I want to know that why population is more here, and okay, this is the population of 2015, and I'm interested to know that what may be my explanatory variables to explain that why the population is high. So let's take the built-up area of 15. Let's take we should not take this because we have already taken population 15 dependent variable, so we will not take here as an explanatory variable this one. We can take this GDP data. We can take here the nightlight data is also available here. Nightlight data is also here. Okay, then we can take these three. Okay, and others are here related to environment like the carbon dioxide or another pollutants material. So before I make it okay, let's see the search criteria here. In the search criteria, you have the option to increase your explanatory variables. Here, maximum number given 5, you can increase up to 20 also. You can increase to 10, or minimum is 1 here. So this is, I mean, optional, and which you can choose. And another important thing is, first, when it is very important to be confident that you have given the right explanatory variables before you hit the button OK. Fine. Thereafter, as you can see, weights matrix file. This is optional, but you can make this file by using this script here, generate spatial weights matrix. Okay, so that we will discuss in later. Here, this is my dependent variable, and these are the explanatory variables. You can give the output report file, which is optional, but let's make it. Okay, let me make it something, maybe PG, something. Save it. So the format will be the text here. If you want your output result table, then also you can give. This will be in PG. Save it here. Um, let's see, make it okay. You can go to the geoprocessing, and thereafter you can go to the result. The current session, this is exploratory regression, and here these are the messages you can see, and choose one. Of course, you can see here this is the summary, and in this summary you can see the your file's location is given here, and these warnings are only just to, not kind of warning, but it's information to you. So okay, let's see what is the adjusted R square with only built up area. It is 0.90. So this is the, it is showing the relationship, and this part is very important. What does it mean 0.90? It means that the population, the variability, the variation in the population data in Ethiopia, in all the urban settlements, can be explained by the built up area. How much? 90%. If you are using GDP is able to explain only 83% variation in the population data. Nightlight is able to explain only 21%. So you got the relationship here. Okay. Now you see another combination, like if you are using GDP data and built up area together, these together, this combination can explain you 91% here. 91%. Okay, if you are using built up area, nightlight, GDP all together, then also 91%. So here you can take the decision that which combination is the best for you. I think built up area and GDP is giving us much more information, so we can use these two data as explanatory variables when we will work on the ordinary least square or this geographically weighted regression. So we have done this exercise here, and we have got the useful information that what is the strength of the relationship and which variables are very useful to explain anything. Means as a dependent variable we can take GDP also. If we are taking GDP data, then in the explanatory we can practice on GDP can explain by the built-up area or the population or some another data which are given there. So in this exercise, as an exploratory regression, it has given us much more information, and this information will help us in the analysis when we'll go for ordinary least square and GWR. So when we were doing exploratory regression, and we saw one thing here, again you can see that weight matrix file, weights matrix file. So here weight matrix file, you can generate, and if this weight matrix, where this weight matrix is required and why it is required, if you will see an analyzing pattern, and if you are looking this spatial autocorrelation, then also there you can see weight matrix file. Yeah, weight matrix file optional. Okay, if I am giving here the data, and in this data the conceptualization of the spatial relationship, this is inverse distance, means as you are moving from your point of interest, then the weight will decrease here. So there is, you see, there is get spatial weight from file. Okay, this is a simple mathematical formulation. Like if you are moving away from a point, from a city, from a town, the weight of that town will decrease. So it is not necessary in all the phenomena, in natural phenomena or cultural phenomena, the weight of anything, we cannot say it decrease. It may have some another some another results. So for that, if I am giving this get a spatial weight from the file, then I have to take the file, this file, and this file will help for making the spatial autocorrelation. So this weight matrix file we can generate with the help of this generate spatial weight matrix. Means it will study the location of the points or the polygons of our data, and based on the the locations and concentrations, the neighborhood, it will give us that what is the spatial weight. So it will generate that file, and in the next video we will discuss about the spatial weights matrix file, what is the use and what is the significance of this file. So this is enough for this video. We have already talked about the exploratory regression, and we got the strength of relationship of the variables. In the next video we'll talk about how we can generate the spatial weight matrix. So thanks for listening and thanks for watching.